that we use scientific notation to represent really, really big or really, really small numbers, right? So we looked at an example, for instance, if we wanted to represent the width of a human hair, which is extremely small, it can be represented as 0.0000008 meters. Or one way that is a little bit more concise is 8 times 10 to the negative 6, right? We haven't lost any of that information when we convert that regular decimal number into a number in scientific notation. And similarly, if you wanted to represent a big number like 100,000, we can represent that as 1 times 10 to the 5. Right? We haven't lost any of that information. The scientific notation is just a concise, a quick way to represent either really big or really small numbers. So you'll notice here in both of those numbers written in scientific notation, there are a couple characteristics to both of them that are common. So any number that you write in scientific notation is going to have 2 parts to it. All right, so we're going to have a number times 10 raised to a certain power. So that number that we have at the beginning here, that is called a coefficient. All right, and that coefficient, in order for that number to be expressed properly in scientific notation, or exponential notation is another name for it, that coefficient has to be a number between 1 and 10. All right, so at least 1, but less than 10. And that coefficient, I think I mentioned this at the end of class on Monday, oftentimes in chemistry we have these big words that mean really simple things, right? Coefficient, big fancy word, that just means the number at the front of the number in scientific notation. So that number gets multiplied by 10 raised to a certain power, right? So those are going to be the 2 parts to every number written in scientific notation. So how do we transform a regular decimal number into a number in scientific notation? Well, we first of all have to decide or note where the decimal point is in the number that we're trying to convert. So for instance, if I have a number like this, 0.000000526 meters. M stands for meters. So this is a regular decimal number. Is it a big number or a small number? Small. Kind of small or really small? Really small. Right? So if I want to convert this to a number expressed in scientific notation, the first thing that I want to identify and locate is the decimal point, which is here. Right? And we're going to move that decimal point either to the left or to the right so that we end up with a number between 1 and 10. So will I need to move that decimal point to the left or to the right? To the right. All right, so I go 1, 2, 3, 4, 5, 6. So I move the decimal point to the right 6 places, and I end up with the decimal point between now the 5 and the 2. So I have 5.26, so that's my coefficient, a number between 1 and 10. And times 10, the other part of the number. And now the number of places I move my decimal point is what my power of 10 is going to be. So how many places did I move it? 6. And because I had to move it 6 places to the right, it's a negative 6. All right, and that's one quick way by which you can take a look at a number expressed in scientific notation and say really quickly whether it's a big or whether it's a small number. And that is the exponent to the power of 10. Right? The negative exponent, or the negative power of 10, means it's a small number. Right, so it may not seem like a big deal, but when it comes to doing calculations down the road and you get an answer and you have to judge whether your answer makes sense or not, you can look at the power of 10 and really quickly say whether you're in the right ballpark or whether you're in the right range. All right, so a negative power of 10 suggests or means that the original number was a really small number. On the other end of the spectrum, if I have a really big number, so for instance, if I have 256 million meters, and I want to convert this to scientific notation. All right, we said the first thing you want to do is to identify where the decimal point is. Where's my decimal point? If you don't see one in the number, where is it understood to be? Where do you assume that it is? At the very end. Right? So if you don't explicitly see a decimal point, it's expected or it's assumed to be at the end. And then we're going to do the same thing. We're going to move that decimal point to the left or to the right, so we end up with a number between 1 and 10. So if my decimal point is assumed to be here, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So now I get 2.56, my coefficient, again a number between 1 and 10, times 10, and then what would be my power of 10 now? So move it 1, 2, 3, 4, 5, 6, 7. So move it 8 places. So my power of 10 there is going to be 8. All right, and because I had to move it to the left, my sign there is going to be positive. And again, that positive power of 10 suggests that your original number was a really big number. All right, so the positive power of 10 means that it's a big number. So these are little things that you can look at when you are dealing with numbers expressed in scientific notation to gauge the relative sizes of them. Right? And that's going to help you down the road once you start doing your calculations and putting these into just some math problems. So hopefully what you've also seen here is that if I had a choice of whether to write this out or to write that one, it takes a lot less energy to write that. Right? And similarly, if I had to write this big number here or the same number expressed in scientific notation, it's a lot quicker to express it that way. So chemists, we make up big words that mean really simple things, and we also like shortcuts. Right? We like to make our life a little bit easier, and the scientific notation does that. Does that make sense? All right, so scientific notation or exponential notation, we have a coefficient, a number between 1 and 10, times 10 raised to a certain power. That power tells you whether it's positive or negative. It tells you whether the number is big or whether it's small. All right, so down here we have some examples of powers of 10 and what they correspond to. So for example, if you have 10,000, that's the same as saying 10 times 10 times 10 times 10. 10 times itself 4 times, which would be 10 to the power of 4. Right? Again, a quick way to represent 10,000. Similarly, 1,000 would be 10 to the power of 3, or 10 times 10 times 10. And if we keep going a little bit smaller, right? 10 times 10 is 100. That's 10 squared, or 10 to the power of 2. 10 is just simply 10 raised to the power of 1, or just 1 times 10. And then 1, right, is equal to 10 raised to the power of 0. Any number raised to the power of 0 is 1. Right, that's a math rule. So those are positive powers of 10, and in all of these cases, with the exception of the last one, they're all big numbers, right, 10 or above. So the power of 10 just tells you you're multiplying 10 by itself that many times. What about on the other end of the spectrum, negative powers of 10? Right, so this would suggest then that we're dealing with small numbers. Right, so 10 to the negative 1 is the same as 1 over 10, which is 1/10 or 0.1. Right? If you stick that in your calculator, you divide 1 over 10, you end up with that 0.1 as your decimal. 10 to the negative 2 is the same thing as saying 1 over 10 times 1 over 10, which is 1 over 100, expressed as a decimal. That's 0.01, and then you continue that all the way through. Right? So the bigger the negative exponent, right? So 10 to the negative 4 is a smaller number than 10 to the negative 3. And 10 to the negative 3 is a smaller number than 10 to the negative 2. 10 to the negative 2 is a smaller number than 10 to the negative 1. So positive exponents mean big numbers, and negative exponents mean small numbers, tiny numbers. The bigger the negative value, the smaller the number actually is. Once we start dealing with these numbers, it's going to make a little bit more sense, especially when we start comparing them or giving you some examples of things that you may encounter that are going to be on these really big or really small scales. All right, so I mentioned that we use scientific notation to represent really big or really small numbers. You really may not want to use it if you have regular numbers. When I say regular, I mean something like 68, the average mass of a human. Right? This is neither big nor small. Right? So you can use regular notation for this. If you have a really small number, for instance, if you were representing the diameter of a virus, like this one here, that's a chicken pox virus. That's a magnification, by the way. The virus isn't that big. Right? Even the coronavirus that's going around now, they're really, really, really tiny particles. Right? It's 0.000003 centimeters. Right? And we know now this means that this should be, well, it is a small number, so when we express it in scientific notation, it should have a negative exponent. Right? We can confirm that. If we take our decimal point, we move it 1, 2, 3, 4, 5, 6, 7 places. Right? And that's where 7 comes from. And then similarly with the 12,800,000, we don't see a decimal point, so it's understood to be at the end. And we move it 1, 2, 3, 4, 5, 6, 7 places to the left, and there's your exponent. Positive exponent means it's a big number. So, identifying and sort of interpreting numbers written in scientific notation is one thing. What's more important is how you use those numbers in your calculations, and secondarily to that, how you enter it into your calculator. All right, so we all have our calculators. Take the calculator out, and let's practice a couple cases here of entering your numbers in scientific notation into your calculator. We practiced this the last time when we were just doing regular addition, subtraction, multiplication, division, etc. Now it's a couple more steps involved. But we're going to enter these numbers just as we see them. All right? And there's a little shortcut in your calculator that you can use to help you enter numbers in scientific notation. And that's the EE or the EXP button on your calculator. Locate that EE button. Can you find it on your calculator? All right, so we're going to enter 4 times 10 to the, 6. All right, so hit 4, and then when you hit that EE button, what that tells the calculator to do is it automatically means times 10. Right, so when you type that in, that tells the calculator that it's times 10, and it's prompting you now to enter what the power of 10 is. Right, so 4 EE, and then in this case it's 6. So it may be a second function, or EXP, on your calculator. So your EE should be, let's see. You may also have 10 to the x on your calculator. So yours is, up here. Right, so EE, EXP, or 10 to the power of x. right? They should all do the same thing, and then you enter the exponent to the power of 10, and if you just hit enter, it will give you what will show up as. Is everybody getting this? The 4 times 10 to the 6. Are you seeing that as your readout? Is it giving you the entire number? 4. Okay, so if it's giving you the entire number 4 and 6 zeros after it, that's fine as well. It's just converting it to a regular decimal number. Let's enter one with a negative exponent, a small number. So 2.5 times 10 to the negative 4. So let's enter that the same way. So 2.5, and then either get the EE or the EXP or the 10 to the Y or the 10 to the X. And now you have to enter a negative number, right? So you hit the plus minus button or the minus sign down at the bottom, that's in parentheses. Then you enter the 4 on there. And it should either give you or display any of these, or it may actually give you the regular decimal number 0.00025. Right? So are you seeing any of those? 0.0025, 0.00025, or 2.5 times 10 to the negative 4. This is extremely important, right? Because you're going to have to do these calculations. You're going to have to enter them into your calculator. And I said this the last time, your calculator is only going to do what you tell it to do. So if you enter these numbers incorrectly, you are going to get the wrong answer.
When I did the 4 times 10 to the 6, it gave me 4.75. When I did the 10 to the...
Okay, see me after class really quick. We can get that squared away for you. All right, are we comfortable? Generally, with entering our numbers in scientific notation. All right, so let's do a quick calculation here, and I want you to do a calculation where we're going to do certain things to these numbers. So I want you to do the following calculation: 1.0 times 10 to the 5 divided by 1.0 times 10 to the negative 5. So you have 2 numbers to enter and you're dividing. Is anybody getting an error message? Yes? Error message? Okay. Does anybody get an actual answer? What did you get? You got 1? Just 1? 1 times 10 to the 10? Confirmation in the back, 1 times 10 to the 10? 1 times 10 to the 10. So is there, at the very right side of your calculator, is there something up on the top that tells you the exponent? No? Okay, so one strategy that you can use, and I would actually encourage you to do this, is when you enter numbers in scientific notation, it's a good idea to put the numbers in parentheses. All right? So open, you should find out, there should be some parentheses on your calculator. Open parentheses, you enter the first one, close the parenthesis, divided by, open parentheses, 1 times 10 to the negative 5, you close it, and then you hit enter again. Should give you the same answer, by the way, 1 times 10 to the 10. It works this time? Yeah, so depending on the calculator that you have, right, you may have to use those parentheses. And it tells the calculator that that thing in parentheses is one number itself, and we're going to treat it like an individual thing. All right, so process of, first of all, understanding scientific notation, entering it properly into your calculator, and then doing calculations with it is going to be things that we're going to be consistently doing from this point down the road. All right, so it's extremely important that you are familiar with using your calculator properly. Right, you shouldn't be fumbling around with the manual when an exam rolls around. All right, that should be the last thing that you should be doing. All right, let's do a couple quick summary here. So we have these two numbers. So what I want you to do is to express both of these as scientific notation. So take a minute. So 64,000 and then 0.021. All right, so 64,000, we don't see a decimal point. We assume it's at the end. Over here, move the decimal point 1, 2, 3, 4 places. So we get 6.4 times 10 to the 4. Right, makes sense. My power of 10 there is positive. We had a big number to start with. All right, 0.021, there's our decimal point. We move it 2 places to the right, so we end up with 2.1 times 10 to the negative 2. Negative exponents suggest that it's a small number that we started with, and it is. All right. All right, so our last thing here. So select the correct scientific notation for each. All right, so for A. So this is a good example of the types of questions that you may see either on a quiz or on an exam or something, where even if you don't know how to do it, you can use some strategies or some intuition to eliminate answers that are immediately wrong. All right, so 0.000008, big number or small number? Small number. So which of these would have to be wrong? 1, right? Because this suggests it's a big number. So we can eliminate that right away. So let's say you didn't know how to do this, and you're going to guess. Well, you can guess 1 out of 3, or you can eliminate that first one and guess 1 out of 2, right? So you improve your odds of guessing it if that's what you wanted to do. But you don't want to be guessing, all right? And then we can confirm this, whichever one it is. So remove our decimal point 1, 2, 3, 4, 5, 6. Right? So that'll be our number expressed in scientific notation. What's wrong with 3 though? What's incorrect about this? The coefficient, right? The 0.8, exactly. Somebody said 0.8. That coefficient has to be a number between 1 and 10. So we can also eliminate that one if we didn't know anything about moving decimal points, which leaves us with the only one. All right, and then similarly 72 million, right? That's a pretty big number. So we can eliminate that one with the negative exponent. We can eliminate this one because this is not the coefficient here is not a number between 1 and 10, which leaves us with that. We can confirm. There's our decimal point 1, 2, 3, 4, 5, 6, 7.